Okay, how can you use properties of operations to write equivalent algebraic expressions? Okay, equivalent expressions are equal to each other for any values of their variables. Okay, so if you look at the examples here, x plus 3 and 3 plus x are equivalent expressions. Okay, if you substituted 4 for x, 4 plus 3 is 7. Okay, 3 plus 4 is 7. So the commutative property tells us that x plus 3 and 3 plus x are the same thing. Okay, so we're going to use our knowledge of number properties and combining terms to write equivalent expressions. Okay, remember equivalent expressions are two or more expressions that are equal for any value of the variable. Okay, so keep in mind you can write equivalent expressions by combining like terms. We have 5a plus 7 plus a. Okay, so I know that 5a and a give me 6a plus 7. So that's an equivalent expression. 5a plus 7 plus a is the same as 6a plus 7. Okay, so you can, there we used our knowledge of combining terms. You could also use number properties. If I were to rewrite this expression, the commutative property tells me I can add in any order. So I could have written 7 plus 5a plus a. Okay, and then I could use the associative property and group those together. Okay, 5a plus a is 6a, and I'd have 7 plus 6a. So you can use number properties or combining terms to help you. Okay, so we're going to write an equivalent expression. The like terms here are the numeric terms. So I'm going to combine those. 5 plus 8 is 13 plus 6m. Okay, and that's the same as our expression up here, or equal to. Okay, so 5 plus 6m plus 8 is equal to 13 plus 6m. Okay, you can also test it by assigning a value to your variables. Let's say m was equal to 5. Okay, I could substitute 5 in there. 6 times 5 is 30, plus 5 is 35, plus 8 is 43. 6 times 5 is 30, plus 13 is 43. So test it out. Make sure it's the same thing. Okay, a couple more. Okay, be careful. This one might be tricky. We have 9w plus 12 minus 2w. Okay, so our like terms this time are 9w and w. Okay, now this one might be easier if we apply the commutative property to our first two terms. Okay, and make this 12 plus 9w. You can add numbers in any order, minus 2w. Now you can see 9w minus 2w is 7w. Okay, combine the like terms there, and 12 plus 7w. Okay, or you could also think if you had 9w and took 2w away, you'd have 7w. Okay. All right, 7v minus 4 plus v. Okay, this is a little tricky, and here's one where maybe you want to model it. So if I had 7v, 1, 2, 3, 4, 5, 6, 7v. Okay, and I'm going to take away 4, and I'm going to add a v. So if I'm combining my like terms, I had 7v, and another v is 8v minus 4. So use all the strategies we've been working on, combining like terms, modeling, okay, number properties. All right, remember the distributive property, multiplying a sum by a number, is the same as multiplying each term by the number and then adding the properties. 5 times g plus 9 is the same as 5 times g plus 5 times 9. Okay, so distribute means to give out. So a couple equivalent expressions here. 6 times 7 plus y is the same as 6 times y, and add that to 6 times 7. Okay. Down here, 8 times m, okay, is 8m plus 8n. And up here we could have looked at that as 6 times y is 6y plus 6 times 7 is 42. Okay, so in the distributive property, you give the multiplication out to each of the addends. Okay, and the final example here, sometimes you're going to get a term like this, 12c plus 8b. And you're going to have to use the distributive property. So, okay, we worked on this earlier in the year. The first thing to do is find the GCF of 12 and 8. Okay, the greatest common factor is 4. Okay, so now if I want to write an equivalent expression to this, I'm going to think 4 times 3 is 12, so it's going to be 3c plus 4 times 2 is 8, 2b. Okay, let's think. 4 times 3c would give me 12c plus 4 times 2b is 8b. So 12c plus 8b is the same as or equivalent to 4 times 3c plus 2b. Okay, remember equivalent expressions are equal to each other for any values of their variables. So if you're not sure if your expression is equivalent, assign a variable and test it. But it can't be true for just one variable. It has to be true for any value, or excuse me, for one value. It has to be true for any value. So try a couple different numbers.